Hi, welcome to Marc Explains. Welcome to the next session of this event sourcing series, Level 3. Level 3 is about architecture. And as we look at the architecture and design graph of 2023 of InfoQ, event sourcing is put in the late maturity. And event sourcing is not on itself, it's more in this area of event-driven architecture, CQRS. It's about eventually consistency in microservices, and it's coming from the domain-driven design. Let's go into domain-driven design. You have sort of two Bibles in domain-driven design. You have the Blue Book and the Red Book. The Blue Book, the domain-driven design from Eric Evans, was the first. And it's all about why it's important to design around your domain. Why is domain so important? What is domain actually? And how is my domain connected to other domains? So it's all about the notion of the domain. And in the Red Book from Vogt Vernon, it's more practical in how you should apply it. How should you use domain-driven design when you're building software? And both books promote a ubiquitous language. This is a language without misunderstanding around verbs, nouns, and terms. So it's really clear what we all mean by every word. And so this is often a lot of domain language coming from the domain experts, but the developers should understand the domain as well, at least understand the language the domain expert is using, as well as the domain expert need to know some parts of the technical language the developer is using, so that the language we're using when we are standing in front of a whiteboard is really clear and can't be misunderstood between the different members of a team. And so you see this language everywhere. You see it in your documentation and your specs, but you also see this language in your application code and your test code. So I wanted to leave it here for domain-driven design. The Blue Book and the Red Book are quite thick and thorough in their description and knowledge about domain-driven design. So please go there if you want to know more. For now, I just want to get into the architecture of event sourcing. And I see sort of three parts in there. There is something about synchronization between the business and the technology, where the ubiquitous language is already part of that as well, and the whole domain-driven design way of working. There are architectural patterns around event sourcing, and it also has some implications on the software level, so there's some software architecture involved as well. But first, let's start with the synchronization between business and technology, because when you have a business, there's a certain rhythm to it. There's a certain flow going in your business, and it is this comes from how your business is organized. This comes from the business you're in. So that's different for every business. There's also a technical rhythm. There's a certain tempo in which the technology evolves, in how often a new release is put into production. There's also a rhythm on the data level, and my observation is that the business rhythm and the technical rhythm is different. They are not synchronized, and I think that's part of the problem. Let's dive a little bit deeper into the technology rhythm, because we often have a hot or cold standby for our data. So there's a secondary database, and that's also called events. There are events for replication from the primary database to the secondary database. So this is basically event sourcing on a technical level. This is very common in database in the database area for decades already. So it's not a new paradigm, the event sourcing way, but it's only applied on a technical level. And well, once we had quite a simple model, let's say, with mainframes, or even after that with our Unix systems in our data centers, and we only had one data center, and then we got two, but still a centralized model with some synchronization between it. And then we came into the cloud era, and now things get distributed, and it's getting more complex, and this synchronization pattern on the technical layer is even more complex. But still, a distributed setup is acting like one. It's still one database, one logical database, or one logical application. But within this application on a Kubernetes cluster or a database with charts or with whatever complexity you have in your database, there's a technical synchronization and eventually consistency going on there. And it gets even more complex when you go into the decentralized networking solutions. So on a technical layer, there are events and synchronization patterns. And on the business level, you could model your business with events as well. And when you do that, you have events on the business, in the business rhythm, and you have events in the technical rhythm. And if you combine them, you just have events, and the whole barrier between the business rhythm, the business tempo of how things are evolving in the business, and how things get synchronized on a technical layer, they become one, and the whole barriers is being removed. So I really love this synchronization between the business and the technical levels. So let's dive into the architectural patterns then, because how can this be applied? Well, the hard part about this is that we are currently used to a state sourcing paradigm, let's say. We have an object, or we have a process, or we have an aggregate, and we have state somewhere in our database. That's a digital representation of the actual thing, or the thing that we are trying to administer, register. We have some digital representation of that. This seems to be fairly simple, but actually it isn't, because this state, we need to write to it, we need to read from it. When we write, we need to check the constraints. We need some history about it, how does this state evolve. And we have evolution over our state, so we have a version 1 of our state and we have a version 2 of our state, and it should all be in this one model, in this one state, in this one database, which is quite complex, and it's often optimized for read or it's optimized for write, but when it's optimized for read, it's not optimized for write. So there are contradictions between what should have a higher priority, the write part of the model or the read part of the model of the state. And this is neglecting that the actual mental processing we do by updating our state is just nowhere. It's not stored anywhere. We're just losing data here. So we need another paradigm, we need another pattern for this. And this is where event sourcing is coming in, where all these things are addressed, but are not all addressed in the same state, but are addressed in different parts of it. The first pattern here is the command query responsibility segregation. CQRS. And this is a split, a separation, segregation of the where do we change data, where do we fire commands to the aggregate to try to update it, and where do we read from, where do we query on the state. So first we have a command which we can fire to an aggregate or to a process or on an object, and in our software, in our application, we need to check the constraints of this command. Is it allowed? Is it valid? Will my aggregate still be in a valid state when I accept this command? When it is, so then we have checked all the constraints, then we need to do an update. And instead of directly updating our state, we describe the motion in our domain model as an event. And this is the event sourcing pattern. So it's the second architectural pattern. And so this event is describing the motion of what should be updated, or what has happened in my aggregate. And after we have this event, we can update our query side. So getting back to the first pattern, the CQRS, we can update our query model or our state, or we can even update multiple states. So there's less complexity in every single query, view, projection, store, database, what you like to call it. It's separated from each other, so we can have the complexity for the version 1 state just in this version 1 model, and the software from going from this event towards this version 1. We can also produce, of course, an historical view on our aggregates, on our models. But the thing is that when we are reading our historical models, often a bitemporal model, we are trying to reconstruct what has happened. But that's exactly what the events are describing. First, this event was happening, then this event came along, then this event has occurred in our aggregate. So the event, the stream or list of events being produced on this aggregate is actually just as we are trying to reconstruct what has happened. So historical analysis is often more easy and quite straightforward on the stream of events instead of a bitemporal historical model. So now we have CQRS, we have the segregation of the command and the query side, and somewhere in the middle we have this event sourcing pattern. Once you produce events, you can also use this event to trigger downstream processes. And this is more of an event-driven architecture. Things are happening on one part, in one side, and the events, the notifications, the triggers that come out of this process, coming out of this aggregate, are triggering the next phase or a next process or the next ripple of changes that should happen in our application landscape. And this is not event sourcing, but this is event driven. And so once you have your aggregates or your systems designed as event sourced systems, event driven architecture can really easily be applied and be connected to your event streams. You could also say that the event is the real truth. This is what actually happened on our aggregate. And my version 1 state or my version 2 state or just this state is derived from this truth of things that happened in my state, on my aggregate. And this also has the benefits of having an audit trail and not having an audit trail as an additional feature, but it's really at the core of the system that you have an audit trail with all the changes that happened on my aggregate and what led to a certain state. So this is the architectural pattern. Let's move to the software architecture patterns then, because how can I see what do I need to do in my application to follow these patterns? Well, today's architecture is often a presentation layer with our web services. Then we have some block of logic connected to our relational database in which we have our state. And of course, we have clients calling our API. It can be mobile, it can be business to business, or it can be a browser application, whatever you have. And then we have lots of patterns around there. We have the model view controller inside the browser or between the browser or a client and your presentation layer. We have XML or JSON coming into our API, so we need to transform that into our objects if we are, for example, doing a Java application. So we have some external object translation into Java objects. Of course, we have our Spring controller, then we have our business service interfaces with the business service implementations in our logic. We have other logic, we have our domain model, and we have an object relational model towards our relational database, in which a schema lives, which maps to our Java classes. And of course, we have unit tests, at least 80% of coverage, and some integration tests, which are more often like close to 5% instead of to 80%, because it's quite hard to test or to know what you should test there. And my first problem is at the top. So we need to apply this CQRS. So we need to apply a different API for our commands and for our queries. So is this just one API, or should this actually be two APIs? A very clear API for our commands and a very clear API for our queries. And when you trigger or call a command API, nothing is returned. Maybe an ID is being returned of something that has been created. So then you can query for this with this ID for the aggregate state, for example. So we sort of solved or implemented CQRS on the API level. But then we have lots of other questions as well. What should we actually test in our integration test? 5% is coverage. Is that really, that's quite low. Unit test, what am I actually testing in the unit tests? Is this technical tests or are these really domain tests? And our business services and our business service implementations, how much do they mimic or how much do they mirror the real business language? Is it actually business language, or is it a technical language on how we evolved in designing our software? And domain model is actually a very interesting name. Is it really the domain, or is it just a data model and lots of the behavior of the domain is missing? Actually, the domain, where is it actually in our logic, in our business services? So, okay, we have applied CQRS. Now we are on the quest for where is our domain. And actually, lots of the domain is about the command side. How can I make sure that my domain and my domain objects are still valid, are in a proper state? And about the querying, that's very small parts of the domain actually. The query logic is often very small, and the biggest part of your domain is about validation and updating the state. This updating validation and updating the state, can we point it out more precise? Well, validation is something different than updating the state. We can even separate that in our code base. And now we are getting there, because now we can have, first we can check for our constraints, we can do our validation, and then we can apply the update of the state. We can even design and we can even model what should be updated. So we can introduce events here which describe the motion of the domain model. And this event can be stored in our database. And it's not really directly mapping to our domain model or the scheme we have in our the schema we have in our database. It's a different model. It's actually a different language. Actually, the commands are a different language than the events, and events have their own language and their own notions. And then we have our state. And the relational database is basically designed only containing our state. So these events need to go somewhere else. And actually we need another type of storage there as well. It's an append only, because events will always be added to the current list of events. And they should be stored in this event store. And once we are having these events in our event store, we can move the whole domain validation, updating of the states, producing of events and storing the events to the command side. And the query side can be very concise and small, just having a listener for the events, having some small logic on how this should produce a certain query, a certain perspective on the events. Probably we have some storage for optimization and high availability or something like that. And of course we have our query API. And it's very easy to have not just one, but have multiple listeners, multiple domain logic on the query side, producing different views, producing different perspectives on the same stack of events. So this is the transition we need to make from our current application architecture with our presentation layer, our logic, and our relational database. We need to split it up, and we need to be very concise in our command side, command APIs, the domain logic on validation, to check, to keep the constraints, to produce and describe what is actually being changed in this state, on our domains, store that event, and then have different and probably multiple listeners producing specific query perspectives, query stores, query views, view stores. All words for the same thing. So this is what should happen in our applications. And with that, I would like to close this architecture part and the architecture part of this event sourcing series. And as you can see, there's a lot of different levels and different perspectives or aspects on event sourcing. Please check out my other videos for the other levels, and I hope you did enjoy this one. See you next time.